Should be all right. All right, so we left off with this one here. We're combining fractional expressions to verify an identity. In this case, we have two fractions on that left side. The left side is obviously the worst side of the two here. It's the more complex. So let's see if we can get that ready to go and change that into our 2 secant of x. Now, as we're talking about this, I see secant, so what am I probably going to be working towards at some point? Cosine, 1 over cosine, right? And if it's 2, that doesn't really change much, but I'm still working towards 1 over cosine somehow. But the first thing I got to do is I got to make this one fraction. There's not much I can do when there's 2 separate fractions. I got to be able to combine these. So how could I combine 2 fractions? I'd find a what? Common denominator. Okay? Let's find a common denominator. So my common denominator here is going to be what? Just the 2 denominators we have, right? 1 plus the sine of x, cosine of x, and 1 plus sine of x, cosine of x. So I'm going to do them separately first. Now, if you remember back to, we did this last year, we did this year, if I want to find a common denominator, then I have to multiply the tops by the opposite one, right? The one you don't have. This doesn't have cosine. This doesn't have 1 plus sine of x. So I have to multiply 2 tops by that. So I have cosine of x times cosine of x. What's that going to be? Cosine squared of x. Over here, I have to FOIL this guy through. So I have 1 and 1 is 1. Okay. And then 1 and sine of x is plus the sine of x. And then I have plus the sine of x again. So I'm actually going to have 2 sine of x, right? So 2 sine of x plus sine squared of x. All right, so I just expanded that thing when I FOILed it. It just became 1 plus the sine of x, quantity squared. Square the first term, multiply 2 together times 2, square the last term by rule. All right, so now I have common denominators. If I have common denominators, can I write this as one big thing now? Absolutely. Absolutely. So now I have cosine squared of x plus 1 plus 2 sine of x plus sine squared of x all over 1 plus sine of x cosine of x. All right. Now, one thing I see that I hope you guys can see, I have a cosine squared, I have a sine squared. If I have those added together, what do I have it equal to? 1. And then look and see what else. Excuse me, what else I have? 1 plus 2 sine of it. Right? That's pretty darn close to this, isn't it? So we got something there we can work with. All right. So let's go ahead and let's rewrite this guy a little bit. Okay? Let's rewrite this. So I am going to bring cosine squared of x plus sine squared of x out to the front. And then still have my plus 1 plus 2 sine of x. All right, I'm going to run out of room here. So all I did was rewrite. Now, I'm also taking more steps here too in these notes, so you guys have something to reference to, okay? Yeah, I'm like that step right I just did right there. That's a step you could skip if you needed to, okay? Now, cosine squared of x plus sine squared of x, that's equal to what? 1. So then I'm going to have, this becomes 1. That makes this 1 plus 1, which is 2 plus 2 sine of x over 1 plus sine x cosine x. Still with me? Now remember I said I had that sine of x that was pretty close to what I have on the bottom. Now I also have two 2's here. Now, could I factor a 2 out of the top? Can I factor a 2 out? Yeah, if I factor a 2 out, then I have 1 plus the sine of x, don't I? And then I can do a little shoo shoo, cancel stuff out, right? So let's pull that 2 out. 2, 1 plus sine x over 1 plus sine x cosine x. Gone, gone. Oh, I forgot. There we go. 2 over cosine x. I'm basically there, aren't I? Okay? If you need to see it, this would be 2, 1 over cosine of x, right? 1 over cosine is the secant. So I have 2 secant x. Is that what I was looking for? Absolutely. Boom. Doesn't that feel satisfying? That's a good check. That's solid. That's a hefty one. That feels relieving right there. Any questions on that? So what did we do overall? One, we saw that we had two fractions. We had to combine the fractions. After we combined the fractions, then the next, I'm telling you how I see this and how I hope we can get you to a point to see this. All right, I see. All right, fractions. I can combine fractions. After I combine fractions, then I start seeing this cosine squared, sine squared. Think replace. Okay, got to there. Then I'm here. Now I'm thinking, how can I cancel? This is pretty close to this. So I factored out 2 so I can cancel, simplify as far as possible. Got me to here, then I can just rewrite that in secant. Make sense? All right. What about this next one? So what I'm really trying to do here with the notes too is I'm going to break down about every variety of ones that you're going to see so you have an example of each type. Got me? All right. Next one. Let's go with this. Multiplying the numerator and denominator by the same factor to verify. We're going to use sine x over 1 plus cosine x. And that's going to be equal to 1 minus the cosine of x over sine x. All right. So I'm going to split this. And looking at this one, we want to go with a more complicated side, right? They're basically identical, aren't they? One just flipped. So it's really 6 one, half dozen the other. All right, let's just go with the left side. All right, so looking at this, kind of our things, there's no fractions to combine. There's nothing to rewrite in terms of sine or cosine because it's already in sine and cosine, right? So we're kind of stuck there. But we have something we could do. We have something we can do to this bottom to try to get rid of this. Remember conjugates? Remember doing those? Anybody? Conjugates. Conjugate is the same expression, just change the sign. So the conjugate of this would be 1 minus cosine x. And also, take note, the conjugate would be the same as the top over here, right? So let's multiply by the conjugate. So I can multiply it by anything as long as I do it to the top and the bottom. 1 minus cosine x over 1 minus cosine x. All right? So on top then, that's going to leave me with sine x minus sine x cosine x. Okay? Now, on the bottom, you know what? I don't even want to do that. I want to leave that unmultiplied. I got ahead of myself there. Sorry if you already wrote that. I'm just going to leave this as sine x 1 minus a cosine of x. Okay? Nothing big there. Now, if you remember, when you multiply by the conjugate, it cancels one of the things out. Okay? So we're going to have 1 times 1 is 1. 1 times cosine x is cosine x. Negative cosine x times 1 is negative cosine x. And then negative cosine times cosine is going to be positive cosine x squared. All right with that? So then these two cancel out, leaving me with 1 minus cosine squared of x. That should be a minus. Okay? Now, I see a cosine squared of x and a minus 1, and a negative cosine squared and a 1. Does that make you guys think of anything? A Pythagorean identity? Cosine squared plus sine squared equals 1. If I manipulate that and subtract the cosine squared over, what do I have? Sine squared of x equals 1 minus cosine squared of x. Right? So I could replace that and have sines to cancel. Let's try that, see what happens there. So now I have sine x, 1 minus the cosine x, over sine squared of x. Looking pretty darn close now, aren't I? Sine's gone, square's gone, leaving me with 1 minus cosine x over sine x. Boom. Right. Yeah. So first off, cosine squared x plus sine squared x is equal to 1. So one of our Pythagorean identities. If I subtract this over, sine squared x equals 1 minus the cosine squared x. Good with that? So that's how I replace 1 minus cosine squared x with sine squared x. Then I have a sine on top and 2 sines on the bottom, basically. If I cancel out 1 sine, sine on top is gone. On the bottom, I have 2 sines, so I only have 1 sine left. Yeah. It essentially is. It's just this whole thing is, you could write it as that, or you could write it as this. Either one's exactly the same thing. This is just kind of more what trig functions. This is traditionally where you write it at. Okay. You guys all right with how I did that one then? Think so? All right. We got 2 more today to shoot for. I'm kind of throwing a whole bunch of stuff at you now. See what sticks, you know? Did you ever hear that phrase? Throw it all against the wall and see how much sticks? There's a certain word I left out there, but rhymes with spit. Yep, that was definitely it. All right, so this one, we're going to change the sine and cosine again if possible. We're also going to use some of our even and odd identity things. So I don't think there's any question on this one. Which one has the uglier side, is there? I mean, it's definitely that left side. All right. Put my bar down there. All right, so I'm looking at that right side. I see tangent of x, so eventually I need to get to somewhere where I have sine over cosine. Right? That's kind of our end game. That's what we're looking for. All right, so looking at that thing, first thing to keep in mind, remember our even and odd stuff that we talked about? So I have a negative sine of negative x. Well, if I have a negative x with a sine, I can pull that negative out front because it's an odd function, correct? And then I have a negative negative sign, so 2 negatives make a positive, okay? What's that? Super negative. We can do that. So that just changed to positive. All right, good with that. Now, let's get things in sine and cosine as much as we can. Let's get rid of that tangent on the top. So tangent is equal to what? Sine over cosine. Okay, so we got sine over cosine. sine of x over cosine of x. Then I'm going to have plus sine of x still, all over 1 plus cosine of x. Now I have a fraction on top and a fraction within a fraction. Common denominator up top. Common denominator would be cosine of x, wouldn't it? Okay, so this one here doesn't need anything. It'd be just 1 essentially. I'll multiply this guy by cosine of x over cosine of x. All right, that's going to give me then sine of x, which is our first term, plus sine x, cosine x, all over cosine x, and then all of that over 1 plus cosine x. A lot going on here, don't we? Step before this one, this was my denominator, right? So my denominators will be cosine x and 1. Okay, my common denominator is going to be cosine of x. So I had to multiply by the one it didn't have. So I multiplied the left one by 1, right one by cosine of x. So sine is here, sine x, cosine of x is here. Just put them both over. They would both be over cosine of x, so I just combine them. No, it's still here. This, that's that one, that's another one. It's still there. Oh, right here? Yeah, I started right sine. I just had to read it. Okay? Now, I don't know. There's nothing else I can really replace cosine sine, is there? But I do have a fraction and a fraction. Let's try to get rid of that. See if that helps us. Take my bar out. So I'm going to take this. Remember, this would be over 1, right? And I reciprocate this up and multiply. So now I have 1 over 1 plus cosine x. All right? Now, can't really see it in that step, but don't I have two sines on the top? And if I factor them out, what am I left with? 1 plus cosine x, right? All right, so bring that out. Now I have sine of x, 1 plus cosine of x, over cosine of x, and then multiplied by that fraction I just brought up. 1 over 1 plus cosine of x. Okay, all I did was just factor this top because there was two signs. All right, so now everything is written as multiplication. That's gone and that's gone. What am I left with? Sine over cosine. What am I looking for? Tangent, which is sine over cosine. Boom. Knocked her out of the park. Right? We're still good? Just a lot of algebra here, isn't there? I mean, really, there's a lot of algebra. It's kind of like just a long substitution problem. All right, last one for the lesson, and you guys get to try them. I know you're excited, aren't you? Chomping at the bit to start knocking some of these out. I'll give you easy ones to start with. And you have a really nice set of examples to look back at too. Right. It won't be a lot. All right, here we go. Last one. We have 1 over 1 plus cosine x plus 1 over 1 minus the cosine of x equals 2 plus 2 cotangent squared of x. This guy's like a level 10, okay? Don't worry, you will not have any of these tonight. Want to try to figure it out? See, here's the only problem with this one. We haven't done one like this yet. If you want, hey, you go out in the hall. We can shut the door, and we'll give it 5 minutes to come back in and see what you got. Okay? Shut the door on the way out. If you're right, I'll give you a homework pass for tonight. Shut the door. Shut the door so you can't hear me. Okay. So. On the right side? No, on the left side. On the left side. Yeah, like that's what you're gonna get to get. We're doing both sides. Sort of. We're gonna have to do both sides on this one. We're gonna get stuck. All right. We're doing one side. So. All right. So both of these sides are ugly, aren't they? All right. They're both ugly. So when they're both ugly, flip a coin. We'll start with the left side. All right. So on this one here, we got two fractions. What do you think we probably need to do? We want to combine them. Right? We want to combine them. So. He's gonna use Slater. Get his phone. Here. He's what? All right. So our common denominator here is going to be 1 plus cosine of x, 1 minus cosine of x, right? That's going to be our common denominator. That's the two bottoms that we have. All right, so on the left side, let's go 1 minus cosine of x. Right side, multiply by 1 plus cosine of x. We're just multiplying by the other bottom. All right. So I bring that together. The left one I have 1 minus the cosine of x. Right side I have plus 1 plus the cosine of x. Okay. So now the cosines cancel out, don't they? They're gone. Boom, boom. So now I have 2 over 1 plus cosine of x, 1 minus cosine of x. Well, on top, you just had a minus cosine and a positive cosine. So it's 1 minus 1, essentially. All right, now, nothing more I can do at the top because it's just a 2. Okay, on the bottom, just want to go ahead and multiply that through. That'd be the difference of 2 squares, wouldn't it? So we have 2 over 1 minus cosine squared x. What's that? You can FOIL that. You can just FOIL that. You're going to get 1 minus cosine squared of x. Okay? Oh. What? For if you have the same terms, 1 plus 1 minus, it's different than 2 squares, yeah. All right. Now, the only thing that I see left now, you have 1 minus the cosine squared of x. That's this guy again, right? So let's go ahead and change that 2 over sine squared of x. That doesn't look anything like that right side, does it? I think we're just kind of stuck, aren't we? All right. So we're to a point where we kind of ran out of things to do on the left side, and we didn't make it look like the right side. So this would be one of those times where we go, okay, let's start manipulating the right side. If we get the right side to be 2 over sine squared of x, then we're done. We verified it. You with me? Okay. We used everything we know how to do. We did combine a fraction together, simplify as far as possible, replace as much as we can. We ran out of things to do. Honestly, the only thing I can do right here is make that back to 1 minus the cosine squared of x, but that makes no sense, does it? So we just did it. Okay, so there's nothing left for us to do there. So let's look on that right side now. Yeah, because I mean, you get to this point and go, I don't know what to do now. All right, if you don't know what to do now, go to the other side and start manipulating it. All right, so let's look on that right side. We got 2 plus 2 cotangent squared of x. About the only thing we could do there is rewrite cotangent, right? Cotangent is cosine over sine. In this case, it's cotangent squared, so it'd be cosine squared over sine squared. All right, so I have 2 plus 2 times cosine squared of x over sine squared of x. All right, we got a little something brewing here because I see my sine squared of x on the bottom of a fraction, right? All right, so now we got to find a common denominator, right? We find a common denominator. So this would all be over sine squared of x. This guy would be over 1. So what's my common denominator? Sine squared of x. Okay, so that means I'd have to multiply this guy by sine squared of x. Okay. I'm feeling some momentum here. Now I got 2 sine squared of x plus 2 cosine squared of x. All right. Now, we got sine squared and cosine squared on top, right? It's almost to the point where we can replace it with 1, isn't it? Let's get that those 2's that are messing us up a little bit, right? So let's factor a 2 out. 2 sine squared of x plus cosine squared of x over sine squared of x. That's equal to what, Woodring? That's equal to 1. Guess what? 2 sine squared of x. Boom! How's that feel? Doesn't that feel good?
Yeah, that was the last one was harder. The last one was all over the place.